Dear students, this class is for plus 2 students because I have taken 2 classes of plus 2 second year like wavetics and different terms related to wavetics, and this class is meant for plus 2 students, basically physics honors students. So this lecture is for core 5 or for second year students. Second year students of physics honors. So those who are passed from first to second year and want to study the honors part, that is the basically core 5 means the mathematical part. So we have studied mathematical physics in our first year, which is called mathematical physics 1. This part core 5 belongs to mathematical physics, mathematical physics 2. So what we have studied in the first year, it is just an extension and the use of first year studies of mathematics. So before going to the topic of mathematical physics, we have to know that mathematics is a major chapter or major subject that is needed most of the times in physics. That's why mathematics is also called as the language of physics. So without mathematics, we can't understand the basics, the applications, the proofs and the theorems of physics. So mathematical physics is an essence for physics. So before going to the chapter, the first chapter, that is called Fourier series. Fourier series. So what Fourier series is and what its uses and how do you mean by series, what's the story behind Fourier the scientist, is the unit 1. This part is unit 1 of your core 5. So these are the chapters and there are too many things in the chapter. Before going to the chapter, there are some basic things or basic terms which you want to study to actually know the outline, the theorems and the series, the application of Fourier series. So first of all, before going to Fourier series, I just give you an outlook or the basic concepts of mathematical physics that can be used in Fourier series. So the first part is, everyone knows it and you have to know it better here. That is called periodic function. So this periodic function actually has the significance and the relation with Fourier series. So this part we have to study first, then some even and odd function, then we will go to Fourier series directly. So periodic function means you always know what is function and there is a prefix called periodic. So if you understand what is periodic, then you can directly understand what is periodic function. So period, what is period? We have already listened this term more and often in your classes, whether in 10th or plus 2 or plus the first year, that the period of this lecture is over and the next period will start. So period basically means a certain time interval. After that time interval, again everything becomes reset, which means the value, the time, the process of a given period is exactly same of the next period. So period means a particular interval of time in which we get the same thing that we have got in the previous period. So periodic function, basically we can define it, we can write that definition. What is periodic function? I will explain detail. A function is said to be periodic. That means a function is said to be periodic. On which condition a function is said to be periodic? If it repeats its value if it repeats its value over a particular period or interval, which means in a particular period or interval we get the exact value of the function which we have got in the previous period. So when you shift from period to period, the value of the function is not changed, which means the function is unchanged or the function is symmetrical. That means the functional value is same for a given period and that will be same for the next period. So if you shift the period, the function will behave similarly. That is the periodic function. So you can write the notes, then you can study what is periodic function and proper definition of periodic function. So you can say that let you have a function f of x. Let f of x is a function, any arbitrary function. It may be x square, it may be x, it may be sin x, it may be ln x, any function. So under what condition the function is said to be periodic? So f of x is a function of x. So if x changes, f of x will change, which means f of x is a function of x. And it will be a function of periodic function when f of x equal to f of x plus t, which is equal to f of x plus 2t, which equals to similarly f of x plus nt, which indicates that the value of the function in the beginning will be equal to the value of the function after t period, or after x changes to t or x changes to x plus t, the function remains same. When x plus t changes to x plus 2t, it becomes same. So after t intervals or after t certain lengths of x, the function remains same. Which means if this condition is satisfied, then we can say that f of x is a periodic function of x. I can give you some examples of periodic function. Example. Let us say an algebraic function. Algebraic function. Let f of x equal to 2. This is algebraic function, which means the functional value of x is 2, which means it is a constant function. It is a constant function. That means the value of the function does not change with respect to x. If you draw a graph of that function, this is the variable x and this is f of x. Whatever be the value of x, you take any value of x, the function is independent of x. That means it always gives a constant value. Let this is 1, this is 2. So it always gives the value 2. For any changes in x, it has a constant value of 2. Then good means this is 1, this is 2, this is 3, this is 4, this is minus 1, minus 2. Similarly, you can extend to left also. So if I take a particular period, let the period is 1. That means from 0 to 1, this is a period or length, the value of the function is 1. Here, so the value of the function is 2. If you take the next period from 1 to 2, because I have taken the period to be unit or 1 centimeter. So when we change the period from 1 to 2, the value of the function is also 2. That means it is not changing. If I take the limit or take value of x from 2 to 3, next period, this is the first period, this is second period, this is third period, and so on. So in every period or in every limit of x, we get the same value of f of x. That means f of x does not change in a given period, or the value of f of x is same for every period. That's why f of x is 2 is called a periodic function. So this function or the graph function also satisfies this condition, because as you take t equal to 2 here, t equal to 1, so t equal to 1. If I take t equal to 1, let's start from 0. X equal to 0. So f of 0 is how much? 2. F of 0 plus 1. That means f of 1 is also 2, which is equal. Then if we take next period, 0 plus 2, t is 1. So f of 2, which is also 2. So in every period or in every limit of x, the functional value does not change. That's why it is also called a periodic function. So we can simply write that every constant function is a periodic function. Any function, 2, 4, 5, 0.2, 0.3, if it is a constant, then it can be a periodic function of any period. If you take the period 2, then f of 2, so f of 0, you will add 2 here. So f of 2. If we take the limit from 1 to 2, that means the interval will be this much. The next interval will be this much. Similarly, the value of the function does not change. So in any period, it is same. That's why a constant function is called a periodic function of any period. That means we do not have a specific period. So I can write it here. You can note it. I can write. A constant function. A constant function is always a periodic function. Of any period. So if you take any period, it is a periodic function. Next, we will simply look for a specific function which is not constant. That means a function which is changing, and we will also define the period in which the function has a constant value or similar value. Next, we famously know or basically we use the sine and cosine function. That I can say the sine and cosine function. These functions are also called as trigonometric functions. Trigonometric functions. So for this function, we will see what is the period of that function, or in which period the function changes its value that it has before the period. So to understand, let us say the value of sin x. So you know sin theta, the variable is theta. So sin theta has a value which ranges from -1 to +1. That means less than equal. That means the lowest value of sin theta is -1. The highest value of sin theta is +1, and all other values oscillate between -1 to sin +1. So sin x has a limit from -1 to +1. We can say sin theta from mod is less than or equal to 1. So it has a value which is less than or equal to 1. If we take a graph of the function, we can see that let this be theta and this is the sin theta. So the maximum value will be 1 and the minimum value will be -1. And between that we get different values of sin theta. Likewise, this is 0. So this will be like. Also in the negative period it will also be like this. So this is 0. This point is pi by 2. This is pi. This is 3 pi by 2. This is 2 pi, and so on. And so on. This is minus pi by 2. This is minus pi. So this is 0. Minus pi by 2. This is minus pi. This is minus 3 pi by 2. This is minus 2 pi. So this is the graph of sin theta on the basis of theta. Okay. So we see for this function, let's take an interval from 0 to pi. So in 0 to pi, it has max, and also we can say that the maximum value is 1 plus 1 and the minimum value is always minus 1. So for a particular interval, let from 0 to pi, it has a spike over the angle theta. That means on the axis of theta axis, it has a spike over the line, and from pi to 2 pi, it has a spike below the line. So these two graphs are never similar. So if you take the period from 0 to pi, then the next period will be pi to 2 pi, because pi will be added, and we see the graphs are not similar. This is different. So it can never be a periodic function in the interval 0 to pi. It is never a periodic function, because from 0 to pi it has different value, and for the next period from pi to 2 pi it has also different value. So these two graphs or these two values are not same. That's why it is not a periodic function over an interval of pi. If we extend the period, let the new period will be 0 to 2 pi. So this is your period from 0 to 2 pi. We see at 0 the value of the function is 0. At 2 pi it is also 0, and in between it is 0. It has a spike over the x axis or over the theta axis at pi by 2. It has a spike below at 3 pi by 2. So if you go to next period, the first period is 0 to pi, and the next period will be 2 pi is the limit. So 2 pi plus 2 pi, 4 pi. So the next period will be 2 pi to 4 pi. The graph will be in the next period, it will be also like this. This is 2 pi, and the next graph will be this is 4 pi. So you see the value of the function or the graph of the function from 0 to 2 pi is exactly same that of the value of the function from 2 pi to 4 pi. So we can say that the functional value or the graph of sin theta is exactly same for a period of 0 to 2 pi. So if you take the next period from 2 pi to 4 pi, it is also got a similar value. So we can say that sin theta has a period of 0 to 2 pi, and in that period we have sin theta as a periodic function. So I can say that similarly cos theta is also can prove. So I can write here sin theta is a periodic function of period 2 pi. That means for a limited period, 2 pi period, it repeats this value. At 0 it is 0, and after 2 pi or at 2 pi it is also 0. At pi by 2 it is highest value, and if you add 2 pi plus pi by 2, it will also give highest value. So after next period, it exactly becomes same as that of the previous period. So the function is periodic over interval of 2 pi. Similarly, we can say that in the negative period, it is also periodic. So the limit of the period is 2 pi. So if we take the value of the period, we can say similarly we can draw cos theta is also periodic of period 2 pi. So cos theta is also a periodic function. All trigonometric functions are also periodic. We can say graphically or by mathematical calculations. So there are so many functions which undergo this periodic functional value, and we can say that these are periodic functions. So this is the basic idea about what is periodic function. And again, for periodic function we can say trigonometrically or always know that sin theta, whatever the value of theta, if we take a period of 2 pi, that means sin theta plus 2 pi, because the formula says whatever the period, if that period is added to the variable, the value of the function does not change. That means if 2 pi is the period and we add 2 pi to its variable theta, it should not change, as we always said. So you know that sin theta equal to sin theta plus 2 pi, which can also be sin theta plus 4 pi, So it is a periodic function. Similarly, sin theta plus n pi. So if there is a period of pi, 2 pi, the function does not change its value. So it is a periodic function of period 2 pi. This is the detailed idea about what is periodic function and how can we graphically understand whether it is a periodic function or not. For any function, let us say a function has a graph. This is the arbitrary function. Arbitrary function. We have not defined it. Let this is 0, this is 2, this is 4, this is 6. Let from 0 to 2 the function has a value like this, and from 2 to 4 it is also a value like this. From 4 to 6 also a value like this. So in every period or in every interval of 2 it gives similar values or it gives similar type of graphs. That means in the first interval it is like this, in the second interval it is also like that of the previous graph, and the third interval it is also like the two previous graphs. So in arbitrary function we have not defined it, but we look that the value of the function is same in every interval. So now it can also be periodic function. You take a note of that, and next we will go to what is even function and odd function. Please take a note of that. So next we will see the basic idea or the basics to understand Fourier series. What is an even function and what is an odd function. So I will compare the two functions here. What is a even function and what is an odd function. So you always know that for an arbitrary function is f of x. Let the function is f of x. Any function. That means the function has a variable of x. So to understand any function, let us consider the value of the function is any arbitrary variable and x is the variable. So there is we know that there is a deflection of coordinates. That means if you take the x-axis as the variables of the function, and if you take x to minus x, it is called the reverse of variable x, or the reflection of the variable x about the origin node. That means if this is the axis, this is 0, this is plus x, then the reflection of plus x in the negative side will be minus x. So when the variable deflects about the origin to its opposite side, we will see how the function changes, because as f of x depends on x, if x changes to minus x or minus x changes to plus x, that means a reflection, then f of x will also change because it is a dependent function of x. So if x changes, f of x will automatically change. So what is even function? We can see that if f of x equal to f of minus x, that means if we change the coordinate or reflect the coordinate from plus to minus, but still the value of the function does not change. That means a function which does not change under the inversion or reflection of the coordinate is called a even function. Again I can say that, or otherwise you can say, if we change x to minus x, if we change x to minus x, then f of x is unchanged. If that happens, we say f of x is a even function. Similarly, if f of x equal to minus of f of minus x, so if I change x to minus x, it will give us an extra minus sign, or a minus sign will be added if we change the coordinates from x to minus x. Under this condition, we can say that f of x is an odd function. So this is the basic idea of even function and odd function. We can take an example. Let f of x equal to x square. So f of x equal to x square is always an even function, because if we change x to minus x, then the value of the function is not changed. We can say, so f of minus x equal to minus x square. If the variable is minus x, then we will put minus x in the place of x, but because it is the square of the given variable. If the variable is x, the function is its square. If the variable is minus x, the function is the square of the variable. That means minus x square, which is equals to minus 1 square x square. So minus 1 square is plus 1 and it is x square, which is equal to f of x. So we get f of minus x equal to f of x. So this is the condition for a function to be even. So we can say that f of x equal to x square is a even function, or is an even function. Again, for this we can say, let f of x equal to x cube. Let an function x cube. So f of minus x equals to minus x cube, which equals to minus 1 cube and then x cube. So this will be equals to minus of x cube. Okay, so we can say that this is equal to minus of x cube is how much? X cube is f of x. So minus of f of x. So we can say f of minus x equal to minus of f of x. Again, similarly, we can take if we take the minus side to this side, then it will be f of minus x equal to minus f of x. So we can change it. F of minus x, same thing, equal to minus f of x. Likewise, we can also change that f of minus x equal to f of x. Because the initial function is f of x and the change function is f of minus x. Same thing. Because this is unchanged and the minus sign can be interchanged anyway. So this is the basic idea of even function and this is the basic idea of odd function. Then we see different functions which are called even or odd. Let's say more examples of even function. Let x4, x6, x10 or x square plus x4. These all are even functions, because if you take x to minus x, the value of the function is not changed. That means it is unchanged. If you take the example of odd function, it will be x cube, x7, x5 plus x. These are called the odd functions. So these algebraic functions which does not change the sign are called even function, and the algebraic function which changes its sign are called odd functions. This is the basic idea of even function and odd function. Except these functions, we have also some trigonometric function which can also be expressed in terms of even function or odd function. Let us say, we can say an even function. Example, cos x. So cos x is a even function, and for odd function, sin x. Sin x is an odd function. Now, an interesting question arises: why we take cos x to be even and sin x to be odd? Because if you take x to minus x, it will be cos of minus x. But what is the value of cos of minus x? If the coordinate is changed to x from minus x, then does the function change its value or does not change its value? We can't know from these given functions. So we know the algebraic function and which algebraic function is even and which algebraic function is odd. So if anyway or in any process, if we can expand either cos x or sin x in terms of these algebraic functions, then we can easily say that whether cos x or sin x is either even or odd. So in the first year, we have studied that there is a series called Taylor series. So Taylor series basically means the expansion of a function about a given origin or about a given pole. So the expansion of cos x, we know that it is like 1 minus x square by 2 factorial minus x4 by 4 factorial plus x6 by 6 factorial and so on. Like this it will increase. And sine function is x minus x cube by 3 factorial plus x5 by 5 factorial minus so on. So this is the basic idea or basic expansion of Taylor series. You already studied it in your first year, so I am not going into details. The aim is that only to break this cosine function or sine function to some algebraic values, and that can only be done if you know the Taylor series expansion. So this is the expansion of a cos x and this is the expansion of sin x. Now deeply look into the function. This function cos x, this is 1, that means constant. So this constant function will not change if we change the coordinate, because constant function does not depend on its value. So this part is unchanged. Next, this x square, we already know that x square is an even function because this does not change value. Similarly, x4 is also an even function. Similarly, x6 is also an even function. So for any term, or if we go further, we see that every term of cos x in its Taylor series expansion gives an even function. So the sum of all even functions will automatically give rise to a function which is even. Clear? If each term of a function is even, then whether you add it or subtract it, it will also give an even function, because there is no chance that a minus sign will be drawn from the function and it will make the whole function negative. There is no chance, because all the functions have even powers. So even powers don't give a minus sign if we change x to minus x. Similarly, if you see this function x, this is x, so if we put x equal to minus x, we will get a minus sign. If you put x cube to minus x cube, you will get a minus sign. If you put x5 to minus x5, you will get a minus sign, because these are odd functions. So automatically we can say the value of sin x will be changed, or a minus sign can be extracted from the whole function if you put x to minus x. So you can say that easily we can say, here you can see cos of minus x equal to cos x. See, if you put minus x, then the value is unchanged, because minus x, because the even power of minus x is same as that of the even power of plus x. Here we can say sine of minus x equal to minus sin x, because we are getting an extra minus sign from each term if you put x to minus x. So this is the condition for an odd function, and this is called an odd function. So sin x is called odd function and cos x is called an even function. So these are the basic idea about what is even function and what is odd function. And what we will know and what we want to know is that how these functions will help us to understand Fourier series. That's the most interesting question. What is the value of the function, or why it is even or not? These are also studied in class 2. But why we are studying in this chapter? Because this will help us, or this will give us an idea about the expansion of Fourier series and how Fourier series has these functions inside it. So before going to Fourier series, an extra thing I want to say about, that is some properties. Okay, note it down. Next we go to properties. The basic property is that property. So these properties are most important because these properties will help us simplify larger problems to smaller parts. The first property is, if we add, we already know that a even function is added to even function is also even function. But the simplest form which you know, and the forms or the properties which will be used, that is an even function when multiplied with an even function. With an even function, it also gives an even function. We can take an example like x square into x square equal to x4. So even function into even function is also even function. Second property, even function, shortcut, I am adding shortcut way. Even function, e for even, a for function, into odd function. So we multiply even function to odd function. It will give us an odd function. This is most important because let us say x square is an even function and x cube is an odd function. The answer is x5, and x5 is an odd function because the value will be negative if you place minus x in the place of x. Next, third property, or similarly, or this is also same. Even function to odd function is odd function, and we can say odd function into even function is also odd function. So if you multiply two different functions, one is even and one is odd, whatever the order, let first even, second odd, or first odd, second even, whatever the order, the answer will be always an odd function. Similarly, we can say let x cube is an odd function, x square is an even function, so x5 is an odd function. This is the basic idea. The third point is odd function into odd function equal to even function. This is important. Likewise, if x cube is an odd function, x5 is an odd function, then the answer will be x8. It is an even function because it has even power, so it will not change its value under the change of coordinates. So this is an even function. So odd function into odd function is always an even function. And the next property is, write it down, and next property. Fourth property, the integration of an odd function. Okay, inside it has an odd function from any limit from minus a to plus a. So the limit is from minus a to plus a. It can be minus 2 to plus 2, it can be minus 3 to plus 3, it can be minus pi to plus pi, depending on the variables. So the integration of an odd function from minus a to plus a is always 0. This property you have studied in your first two classes. So the fifth property is integration of an even function from minus a to plus a. You can say is equals to 2 times integration from 0 to a of that even function. Okay, this is understood or not? So if you take a even function inside an integration with limits minus a to plus a, the value of the integration will be exactly same if you take 2 outside the integration and change the limit from minus a to plus a to 0 to a. That means if you take half of the interval, this is the full interval, minus a to plus a. The half of the interval is how much? 0 to a. Because if the interval is 0, this is a, this is minus a. So initially for this integration we have an interval from minus a to plus a. Full interval. If you take a half interval from 0 to a, this is a half interval. So the value of the function in the half interval is that of the value of the function in the interval that was previously here. That means the total value of the integration from minus to plus a will be double, because this is one part, this is one interval, this is one step, and similarly we have 0 minus another step. So the value of the total function from minus to plus a will be the double. That means this is one part and this is the other part. So this is the double 2 times of the functional value of 0 to a integration. So these two properties are most important. These properties can be used to study what is even function and how an even function can be integrated or how an odd function can be integrated. So this is the basic idea about the even function, odd function, and what is an periodic function. In the next class, I am taking this class as a fundamental class, and in the next class we will directly skip, or indirectly we can say that all these chapters or all these sections that I have given here, this is also in a course. If you see your course, the first part is periodic function, then what is even function, odd function. Next class we will see the orthogonality of sine and cosine function. This is an interesting one. In the next class, I will explain what is orthogonal property and how orthogonal property changes the value of the integration from a certain limit. So for this section, this class, this is over, and next classes we will study further on the Fourier series. Thank you.